So, Arvind, this is very visionary, and as I reflect back on what you have said, it seems to me that generative AI is predominantly solving for that 10x factor when it comes to productivity. But if you're talking about complex world problems, you're gonna still need to solve them in zeros and ones and zeros in the quantum era. What's the holdup? What's right now the latest in terms of qubits and fixing that error correction piece?
Yeah. So quantum power is mentioned in qubits. Like, we heard some of the examples. Those are measured in number of GPUs. So in floating point operations, quantum is qubits. So let's just keep it simple. So we are at 1,000 qubits today. People used to bet with me 5 years ago that we'll never cross 16 or 30. We are at 1,000. That's real. You can access that on the IBM cloud. You can go play with it remotely. Those are not simulations, real quantum computers. We need to get to about 20 times more, no longer 100 or 1,000,000. And so you mentioned error correction. People used to claim you need to expand the machines by 1,000 times to make them error-proof. So for 1,000 real qubits, you need 1,000,000 or 10 million. No longer the case. To get 1,000 real, you need maybe 20,000 qubits. So we're about 10 to 20 times away from where we need to be. We've been advancing at about 3 times every year. You can kind of do the math on that, and my confidence now on that 3 to 5 year time frame. And this is now, I would assert, an engineering problem, maybe a hard engineering problem, but no longer a science problem, meaning we don't have to prove can it be done. It can be done, we just need to now get there.